A very good morning, and you're welcome to today's Signpost webinar. I hope you're keeping safe and well. The series is brought to you by Teagasc Connected in association with Dairy Sustainability Ireland, the National Rural Network, and Food Drink Ireland SkillNet. And so this morning, today on the Signpost webinar, we're going to be focusing on sheep systems. And to date, we've largely focused our discussions on cattle and dairy production systems. So today, we'll be looking at measuring methane in Irish sheep systems and what is the carbon hoofprint of the sector in Ireland. And delighted to be joined by Drs. Noirin McHugh, Dr. Fiona McGovern, and Dr. Jonathan Herron, who are going to be speaking to us today about the sheep sector in Ireland. And Andy Boland, you're going to help us with questions this morning. Good morning, Andy.
Morning, Mark.
How's all in Tipperary today?
Very good. Very good. Unfortunately, we've no Munster final on Sunday, but that's
yes, yeah. We won't stick our finger in that wound today. So if I could ask Fiona and Jonathan and Noirin to turn on your cameras and join us. You're being very shy this morning. So if I could start with you, Fiona, and maybe you could just tell us a little bit about the work that you're doing. You're based in Athenry.
Yeah, that's right, Mark. So I'm a research officer based at the Sheep Research Centre in Athenry in County Galway. My main role is working on genetic and non-genetic factors affecting production and looking at production efficiencies across the sheep sector.
Great, thanks Fiona. And Noirin, you're coming to us from Moore Park, is that right?
Yeah, the sunny side this morning, yeah. Yeah, so my role here in Moore Park, I'm a sheep and beef geneticist. Most of my work is supporting the breeding program, the national breeding program for sheep and beef, and trying to improve the profitability and sustainability of both industries.
Excellent, thanks Noirin. And Jonathan, you're also coming from Moore Park. Good morning to you.
Yeah, hi Mark. My name is Jonathan Herron. I'm a researcher based in Moore Park, as you said, and the area I'll be focusing on is greenhouse gas emissions modelling from ruminant systems in Ireland and identifying management practices that can reduce emissions and identifying different mitigation strategies, I suppose. Yeah.
Great, thanks, Jonathan. And Fiona, there's something happening in Athenry on the 18th of June, if I'm not mistaken. I know some people might have noticed a little flyer there during the introduction. Fiona, maybe you could tell us more about this big event you're having on the 18th.
Yeah, that's right. So for the first time in 4 years, so since 2018, we're having a open day for sheep in Athenry on Saturday, the 18th of June, so just 2 weeks away. So it's a public event and it's free for everybody to attend. We're opening our gates from 10 o'clock in the morning and we'll be open right through the day. So we're showcasing the Teagasc Technical Research Programme, messages from right across Teagasc to do with signpost, sustainability, profitability, and ways that you can improve efficiency on your sheep farm.
So really it is a must attend event for any sheep farmer in the country. So all roads will be leading to Athenry on the 18th of June. Thanks for that, Fiona. So Jonathan, I think you're going to kick us off this morning with your part of the presentation. So if you could share your screen with us, and just while you're doing that, to remind everybody that you can send us, and we really do want to hear your questions using the Q&A tab at the bottom of the screen. The session is being recorded and will be available on the Teagasc YouTube channel, along with the presentations. Then will also be available on the Teagasc main website. And if you don't get a chance to watch our webinars live, you can also listen to them on the podcast. So I'll hand over to you, Jonathan, and Noirin and Fiona, and we'll talk to you shortly.
Perfect. Yeah, so as I said, my name is Jonathan Herron. I'm based in Moore Park, and today myself, Noirin and Fiona will be talking to you about greenhouse gas emissions from the Irish sheep sector, specifically methane, and how we can reduce the greenhouse gas emissions. So just to begin with, just to provide a bit of context, what exactly is the Irish sheep sector? So the Irish sheep sector is largely focused on spring lamb production. It's the dominant system in our country. And as of 2020, there was 2.7 million breeding ewes in Ireland. And you can see here on the right hand side, the top graph, the population of sheep in Ireland peaked in 1993 at approximately 9 million sheep. So that's including ewes, lambs, replacements, as well as rams. And there was a gradual decline from that point down to 2010, where it reached its low point and has increased marginally up until today. However, it is very, very small. Of the breeding ewes within Ireland, it's dominated by lowland breeds. So that's your Suffolks, it's your Charlies, it's your Texels. So that makes up to 80%. And then we have 20% coming from hill breeds. So that's your Blackface and Mountain ewes and your Chevets. These sheep, they are, I suppose, they're spread across 35,500 farms in Ireland, so that have some form of sheep enterprise, where the average farm has 83 breeding ewes. This is all coming from the CSO's latest report. Within that 35,500 farms, 17,400 are specialised sheep farms. So it's either the dominant system or else it's the sole system. Ireland itself, we're 335% self-sufficient in sheep meat. So as a result, we export a large quantity of sheep meat, where we're one of the largest in Europe. And in the most recent Board B report, our Irish sheep meat exports came to a value of 420 million. And this is an increase of 12% based in 2020, so quite a substantial increase over a one-year period. Our largest market is actually Europe itself, with France being the largest market within Europe, where we're exporting approximately 30.5% of that value to France. So while this is all very positive, and the outlook, the economic outlook for the sheep sector it's relatively positive, it's also very important to note that sheep are ruminants, and as a result, they do emit greenhouse gas emissions. And livestock has been identified at international level and national level as being a notable source of greenhouse gas emissions, where in Ireland, 37% of our national emissions come from the agricultural sector. And this is a comparison to an EU average of 12, and it just kind of reflects that we're an agriculture-based country. We've less industry related emissions in comparison to our other European counterparts on the continent. And it's also reflective that our agriculture sector is dominated by ruminant systems, and even more so dominated by cattle systems. We can see here on the top right hand side, this is our trends in national agricultural greenhouse gas emissions. Where of today, of 2020, we have emitted 21 megatons of CO2 equivalent in that year, and it's dominated, as you can see in the blue bar, enteric fermentation, which is your methane. When we look at the sheep, then the sheep emissions follow the same trend as the population graph I showed previously. So it reached a peak in the mid 1990s, 1.6 megatons in 1995. Decreased to 2010, and since then it's relatively flatlined, if not a slight increase in emissions since then. Where the sheep, the animal emissions coming from the sheep sector contributes approximately 1 megatons to our national agricultural emissions. So relatively small in comparison to the cattle sector. However, regardless, the agriculture does contribute, as I said, 37%. So therefore, it has to be at the forefront in terms of mitigating greenhouse gas emissions and ensuring that we reach we meet our international obligations to reduce our emissions and reach our targets that have been set for us. To see this happening, to allow this to happen, we need to know exactly what is the baseline, and what we do to do that. We need to know what are the greenhouse gas emissions being emitted at a farm level, and what management practices can be implemented to reduce greenhouse gas emissions. The method which we use to calculate this is life cycle assessment. So not only do we just look at the emissions that occur on farm, we also need to account for emissions that are generated through the production of farm inputs. So the likes of your fertilizer, your concentrate, your electricity. And essentially what this is, we are calculating the total greenhouse gas emissions up to the point in which the product leaves the farm gate. So whether it's the lamb, a cull yoke, a ram, or wool. When we do that, we calculate the total emissions, and then we can express that depending on the metric of choice. So you could do it per kilo of live weight sold, per kilo carcass weight, or per hectare. So when we apply this, we can calculate the average carbon footprint of a sheep system within Ireland. So exercise myself, Noirin and Fiona done recently is we pulled from the likes of the National Farm Survey and CSO, what is an average lowland sheep system in Ireland? And this is the data that we obtained. So on average, the stock rate is around 7.7 ewes per hectare. The average sheep uses 73 kilos of nitrogen per hectare. Average lambing month is March. However, it is important to note that it's spread across a number of months within in spring. On average, the lambing rate is 1.5 lambs per ewe, but when it comes to weaning, an average ewe weans 1.37 lambs per ewe, and this is at a weight of 30.7 kilos. The target drafting weight, so the slaughter weight, is 45 kilos, and that is to achieve the target industry carcass of 20 kilos. So this is what is deemed as an average lowland system. When we simulate this and we put this into our life cycle assessment model, what we get is an average carbon footprint of 10.7 kilos of CO2 equivalent per kilo of live weight. And when we express it on a hectare basis, it's 5.8 tons of CO2 equivalent per hectare. When we look at the breakdown of where the emissions are coming from an average sheep system, we can say the dominant source is methane in the blue bar, and this is just through the fermentation of feed by the sheep themselves. The second main source would be nitrous oxide, and this is coming from the likes of the application of the synthetic fertilizer, which is dominantly used for the likes of silage production. And then we have emissions coming from manure. So manure when the sheep are out grazing, and when the sheep are indoors on a silage-based diet, and how that manure is handled. And then finally, we have carbon dioxide emissions, which contributes approximately 16%. And this is sourced from the likes of concentrate feeds production, as well as the use of fossil fuels on farm as well as off farm. So that's where we are that's our baseline. So from that point, we know where we're starting. How can we reduce our greenhouse gas emissions on an average farm to ensure that we can contribute to greenhouse gas mitigation and allow us to achieve the targets that have been set? So Teagasc have released or have published the marginal abatement cost curve. And within that, there is a number of areas that can be applied within the sheep sector. So firstly, improvement of grassland management. So to begin with, from the soil up, if you correct your pH to the target of 6.3, address any P or K issues in achieving that P and K index of 3. That'll allow you to it'll help you to establish white clover in your sward, as well as the incorporation of clover in your sward. That'll allow you to reduce your reliance on synthetic fertilizer, which is both economically beneficial, but also beneficial in terms of reducing greenhouse gas emissions. Adopting a rotational grazing system will ensure that there's high quality grass in front of the lambs at all times, which will essentially help you to reduce your requirement for the purchasing of concentrate feed, which, as similar to fertilizer, is a financial burden. And that will also contribute to allowing that animal to express itself to reach its optimum live weight gain, which will reduce the time period from birth until slaughter, which will reduce the total lifetime greenhouse gas emissions. Other areas that could be improved, that could be adopted, is like your fertilizer type. So switching from can-based fertilizer protected urea, and this has been already highlighted within this webinar on a number of episodes. And then finally, genetic selection. And Noirin is going to go into this in detail, but how this improves, reduces emissions is you're increasing the number of lambs survived and to weaning per ewe, and you're also, through selecting appropriate sires, you can increase the daily live weight gain for those lambs. So that's just where we are at the moment. So as I said, average carbon footprint is approximately 10.7. We know what practices are available to us that we can reduce those emissions. What needs to be researched further is, first of all, our national inventory is based on a tier 1 methodology. So it may not be representative of sheep in Ireland, but also it may do. It's not flexible enough to allow us to basically see the reward of adopting such mitigation strategies. So that's something that needs to be addressed. Secondly is our life cycle assessment. It is a tier 2 methodology, so it's more sensitive than what's in the inventory. However, it is largely based on international studies, not necessarily coming from sheep within Ireland or even the production systems in Ireland. So to develop country-specific emission factors for sheep sector is an overarching objective at the moment for Teagasc. And this will flow into what Fiona will be talking about, which is methane. So this, as we said, methane is the dominant source of greenhouse gases. You're over 60%. And Fiona will talk about the research that is being conducted in methane emissions in Ireland. So thank you very much. I'll let you share, Fiona.
Perfect, thanks, Jonathan. Sorry, now bear with me for a minute. Okay, I hope everyone can see that okay. So as Jonathan said, while sheep are overall a small contributor to our national greenhouse gas emissions, they are still a ruminant animal, and 64% of our total greenhouse gas emissions is coming from methane. So it is something that we need to look at across the sheep sector, and to date there has been very little work done on it, but it is now one of our focus areas here in the sheep research programme. So I will go through with you some steps that we're taking to measure methane within our sheep systems, and to put some data behind our baseline values, and to investigate how we can mitigate methane from our sheep systems even further. So I suppose when you think about methane, obviously we can't see it. It's a gas that's produced from all ruminant animals. Similarly to how we as humans breathe out carbon dioxide, our sheep or cattle will actually burp or breathe out methane. So about 85 to 90% of the methane that's produced is actually produced out through the mouth and nose of the animal. And essentially it is a waste product of digestion. So when the animal is eating a fiber source, so whether that be grass or silage or another forage, they're digesting it, and there's excess hydrogen released into the rumen. So there's microbes living in the rumen, and they convert this hydrogen into methane gas so that it can be excreted from the animal. So if you think about it from a nutritional perspective, the methane that the animal is producing is not only a waste product, so it's costing the animal energy to be able to produce it and to excrete it, but it's also meaning that the animal is not utilizing the food that they're eating to enough of an extent as they're producing more waste product. So I think we need to look at it this way, as well as seeing it as a negative for the environment and something that we need to mitigate. It's also costing us money and energy to our animals if we're feeding them in a manner that means that they're producing more methane. So there are multiple levels that we can look at it at. So I will go through some methods with you now as to how we measure it across our sheep system. So there are respiration chambers. Some of you may or may not be familiar with these. So they are literally glass boxes that the sheep go into, and they remain inside the chamber for a period of time, and their methane and carbon dioxide output is measured throughout this period. So the next picture is showing portable accumulation chambers, and I will talk about these in more detail in a few moments. And the final picture is looking at SF6, or the sulfur hexafluoride dioxide technique, which measures animals at pasture using the space-like apparatus that they're wearing here in the picture. The final method that can be used to measure ruminant animal methane production and is routinely used in Ireland for measuring methane from dairy and beef animals are green feeds. But to date, we don't have green feed monitors for measuring within our sheep system. So I'll just talk in a little bit more detail about each of the apparatuses. So the respiration chamber, so it's a glass box and one animal fits in each chamber and they stay in there for a 48-hour period. So as you can see in the picture, we can measure their feed intake and their water intake during this time. They are deemed the gold standard for both sheep and cattle methane measurements. So across the world or internationally, they're deemed as the gold standard method. They allow for feed and water intake, and the values that we get from animals in respiration chambers are accepted into our national inventory calculations. So as Jonathan spoke about, if we want tier 2 calculations, the respiration chamber values are accepted into that. The negatives, I suppose, from the respiration chambers then, so there is low animal throughput. The chambers are very expensive both to build but also to operate, and you can only fit in one animal at a time. It is quite a labor intensive method because when the animals are in the chamber, they need to be supervised and they obviously need to be individually fed each day or sometimes multiple times during the day. The animal is also not in their natural environment when they're in the chamber. As you can imagine, a sheep is used to being outdoors grazing, but when they're in the chamber, they're in a housed situation. When we look at the SF6 technique then, so the individual set of equipment is required per animal, and a measurement run will take approximately 6 days. There are really good correlations or relationships between sheep measured using SF6 and also using respiration chambers. So we're seeing a correlation or a relationship of about 0.7 between the two techniques. You want that number to be as close to 1 as possible, so it is quite good. They allow animals to be measured at pasture, so the equipment is fitted onto the animal and then they're allowed to go out and graze, and they wear the equipment for a full 24-hour period. And each 24 hours, the canisters on the top of the animal's back are monitored and the gas is changed within those. And these values are also accepted to the national inventory. Obviously some negatives associated with this, as you might imagine. So again, there's some low animal throughput because you need a set of equipment for each individual animal. It can be quite expensive technique, mainly due to the equipment required, and it is labor intensive. As you can imagine, the sheep can have a lot of fun trying to scratch and take the equipment off. They get quite used to it quite quickly, but yeah, making sure that it's in a stable position on the animal can be challenging. And then the final method that I'll talk about are the portable accumulation chambers, or pack chambers as we refer to them. So they're a series of 12 aluminium boxes that are mounted onto a trailer. Teagasc have pack chambers now since 2019, and we purchased them from New Zealand. So we're the first country in the Northern Hemisphere to have pack trailers for sheep. So you can fit 12 animals per run. So it's 1 animal per box, and you can see 1 box here in the picture, but our trailer has 12 individual boxes. So we have capacity to measure up to 72 animals per day using pack chambers. A measurement run takes 50 minutes. So the sheep enter the chamber for 50 minutes. And during this time, their methane, oxygen, and carbon dioxide is recorded. So some positives to using the portable accumulation chambers: the values correlate quite well, so moderately to strongly well, with the respiration chambers. And we've carried out some work in Teagasc where we've done a validation experiment comparing the pack chambers directly to the respiration chambers, where we've seen a correlation of 0.55 between the two techniques. And then we've also done some work comparing the pack chambers to the SF6 equipment. So it allows animals to be measured from a pasture-based diet, so they can come in from the field, go through the chambers and go back out to grazing. There is obviously higher animal throughput than the last 2 measurements I talked about, and it is more labor efficient. So you're getting more animals done for the same, I guess, labor cost. Some negatives associated with the chambers. So the values obtained from the portable accumulation chambers can only be used as a ranking tool. So at the moment, they're not accepted into the national inventory, both in Ireland or in New Zealand. It is something that we are working on, but for now, they can only be used as a ranking tool. So we can rank one animal versus another, or if we wanted to look at one diet type versus another, one breed type versus another, for example. The equipment is moisture sensitive, which in Ireland isn't ideal, as you can imagine, but we found that there's been no issues once we're under a roof or within a shed for measurements. So I'll just explain to you in a little bit more detail how we're collecting the data using the pack chambers. So the animals are removed from feed for a minimum of 1 hour before they enter the chambers. Their live weight is recorded on the day of measurement. They enter the pack for a 50-minute period. And then during this time, so at 0 minutes, so straight away when they enter, 25 minutes after entry and 50 minutes after entry, their methane and carbon dioxide production and the oxygen consumed by the animal while they're in the chamber is recorded. So by taking these measurements, it allows us to extrapolate the values and to give us a grams per day value of methane output from the animal. So what have we done so far? So to date, we've collected over 7,000 methane records from animals. So we have over 1,800 records from lambs, over 800 records from hoggets. So they're dry animals between 12 and 24 months of age. And then we have over nearly 4,500 records from ewes. So they're female animals over 12 months of age, over 24 months of age who have produced a lamb. So in total, we've measured nearly 2,700 animals across 4 sheep flocks. And starting just last week, our technician here, Owen Dunn, has started to go out to both pedigree and commercial farms measuring methane. So he'll be visiting a range of farms across the country, and Noirin will mention that in a little bit more detail later. So just to give you an idea of what the methane output is looking like from animals at different production stages across our systems. So as we can see from the graph, we have methane outputs in grams per day from lambs, hoggets, dry ewes, and lactating ewes. And as you might expect, the lowest methane production is from a lamb, where the greatest methane production is from a lactating ewe, and that's regardless of live weight. And you might ask yourselves why this is the case, but when I show the next graph, and this is the dry matter intake of the animals, which we've also measured at grass, so their methane output directly follows their dry matter intake, which is directly related to their production. So as you can imagine, a lactating ewe at peak lactation, where she's rearing 1 or 2 lambs and producing milk, she's eating approximately 2.5 kilos of dry matter every day. She is producing more methane, but she's also under more production pressure and consuming more energy. So how do our methane output values from sheep compare to those from dairy cows or from beef cattle? So I've just taken some data from other studies that have looked at dairy cow methane output and beef cattle methane output using respiration chambers and SF6 as the 2 measuring techniques. So as you can see, the dairy cow has the highest methane production. Again, not surprising given the fact that she is under the most production pressure and producing, large quantities of milk for the amount of food that she's eating. The beef animal is somewhat lower than the dairy cow, but still producing about 200 grams of methane a day, which obviously looks quite large compared to the sheep here on the far right hand side. So you can see from the respiration chamber and the SF6 technique, the sheep is producing on average about 32 grams of methane per day. And I know you're all saying to yourself at this point, oh, that's great. Sure, the sheep is fine. We're so small compared to the others, but that's exactly it. The sheep is so small. So when you look at it on a per kilo live weight basis, you have to remember that a sheep is about 10 times smaller than a dairy cow in terms of live weight, but their methane output is the same per kilo live weight as a dairy cow or a beef animal. And I think sometimes we can, maybe be too quick to assume that the sheep are okay because they're small animals. And yes, that is true. But when you look at it per kilo live weight, they're relatively the same as the dairy and beef animal. So it just means for us as farmers, we all need to do our bit, and the onus is on all of us, whether we're farming sheep, beef, or dairy, or tillage or pigs or anything else. We need to take on measures that are going to help to mitigate methane across our systems, but also improve our profitability and our production efficiencies. So it's a win-win for everybody. We've also looked at some of the factors that are affecting methane output across our sheep systems. So the age of the animal directly impacts their methane output. And for a ewe, her parity, or the number of times she's given birth to lambs, has an impact on methane output. Similarly, the live weight of the animal, as I just spoke about, and also for lambs, their weaning weight will directly affect their methane output within that first year of life. The body condition score of the animal has been shown to affect methane output, with ewes that are in poor body condition having higher output values than ewes that are in ideal body condition. And again, that relates back to her, being under pressure. And if a ewe is under pressure to try to, maintain her energy, she's eating more to try and do that, and therefore she's producing more methane. When we look at rearing litter size, so we can see that it is impacting methane output. The time off feed, so when we measure animals in the pack chambers, they're removed from feed for a period of 50 minutes. And if we extend the time that they're removed off feed, we can see that the methane output declines, but that's just due to their rate of digestion. And then the diet type that the animal is on. So we've measured animals on a perennial ryegrass-based diet. We've measured animals grazing perennial ryegrass plus companion forages, and we've measured animals from silage-based diets and from alternative forages, and Noirin will talk through some of these results. So I'll hand it over to Noirin.
Thanks, Fiona. So just to follow on from Fiona then and discuss some of the strategies that we can use to reduce greenhouse gases. So again, this is accumulation of the work that Jonathan and Fiona have already mentioned. And this is a lovely graphic that has been done by the Signpost programme in conjunction with Fiona and Philip Creighton in Teagasc to show 10 steps that farmers can implement on their own farm to help to reduce greenhouse gas emissions. So I'm not going to talk through all of these as Fiona and Jonathan have mentioned a lot of these already, but just to highlight some of the lower hanging fruit or some of the steps that could be implemented quite quickly on sheep farms are management practices such as grassland, using protected urea, using the low emission slurry spreading, maintaining your soil fertility and applying lime. So Jonathan has already mentioned these, and these can give us quick gains in terms of reducing our greenhouse gases from sheep systems. What I'm going to focus on more today is on the breeding element, is what we can do from a breeding point of view, be it from finishing lambs earlier, increasing the proliferation of our ewes, or using Eurostar indexes to help to reduce the methane emissions on our flocks. And finally, then I'm just going to mention briefly some of the dietary work that Fiona is has currently ongoing in Athenry, Teagasc Athenry, and its potential impact on reducing our greenhouse gases from the overall sheep sector. So just to start off with breeding, one of the first things that we've looked at is what is the impact of proliferation or increasing our actual production from the ewe in terms of reducing greenhouse gases. So to start off with, we've used data from Teagasc Athenry on a study that Philip Creighton undertook on the research demo flock, where he looked at 3 different stocking rates, which is what's illustrated here, where he looked at a low, a medium and a high stocking rate. They represented 10 ewes per hectare, 12, or at the high level of 14 ewes per hectare. So slightly higher, the low, slightly higher than the national average at about 7.7, as Jonathan mentioned, but they're representative, I suppose, of your lower base right up to the high base. Across each of these stocking rates, Philip ran a trial which had 2 different proliferacies, so 2 different weaning rate potentials of the ewes. So there was at a 1.5 lambs weaned per ewe and then a 1.8 lambs, so a high and a medium proliferacy. So that trial ran for 4 years, and all the data was collected over the production year. So starting at mating, all housing data was collected, lots of information was collected at the lambing time as well, and then it followed all the lamb growth performance throughout the year and the ewe performance in producing a finished lamb. So like I said, this table just highlights all the data that was collected on each of these 6 systems. Remember, we've three different stocking rates across two different proliferacies or weaning rates. And all that data showed that there was big differences in terms of your stocking rate and proliferacy. What we wanted to do, rather than look at the performance, was to link it to the actual economic output or economic potential from each of these systems. So like I said, we took the real life data from the farm from the research demo farm in Athenry, ran it through what we call our bioeconomic model, and that give us a value in terms of net profit of each system. And that's highlighted in the graph here in terms of the net profit across each of the 6 different systems. And as you see, pretty much as you increase your stocking rate and your proliferacy, we saw a lift in profit going from a low of €361 per hectare up to €802 when we had a high stocking rate and also a high weaning rate of our ewes. So it showed that there was lots of lifts in performance and a lift in terms of economics that could be achieved through lifting stocking rate and our weaning rate or our proliferacy of our ewes. But the next question was, well, what does that do to greenhouse gases? So as Jonathan mentioned, he has his LCA model, his life cycle assessment model. And what we did is ran these figures through his model to see what is the actual greenhouse gas intensities from each of these systems. So again, remember, it's on real life data, real farm data coming from the research demonstration flock in Athenry. And here is a graph of the greenhouse gas intensities from each of these 6 systems. What I want to highlight here is really that as you increased your proliferacy, so if you could wean 1.8 lambs per ewe, what we saw is that there was a reduction in the greenhouse gas intensity in terms of our output when we expressed it in terms of our kilograms of carcass weight produced for each of the systems. So it shows that proliferacy, in selecting a ewe that can wean more lambs, it will reduce our greenhouse gas intensities. So it's one of the strategies that we can use to reduce greenhouse gases from the sheep system. So that's well and good that we have this proliferacy, but how do we actually go about selecting these animals? So the next step that we wanted to look at is looking at our Eurostar indexes. So these are the indexes that are operated by Sheep Ireland, where rams are ranked in terms of their replacement potential, including proliferacy, like I mentioned, and also ranked in terms of their terminal potential. So what we had here was 2 different scenarios. We looked at the 5-star animals, so the best animals in terms of their genetic potential for replacement or terminal traits, and we compared them to the 1-star animals. What we wanted to see again was what would be the lift in performance, in profitability, and finally in greenhouse gases between these. So again, we used real data to actually model this. So we took data from the Sheep Ireland CPT or Central Progeny Test flocks. They're a flock of about 2,500 ewes across 4 different farms spread across Ireland. They're all commercially run farms. We collect all that data from them. And from that, we wanted to look within their population, what was our 5-star animal achieving for us compared to our 1-star animal. When we look at the performance differences, there was lots of performance differences, but I just want to highlight 2 of the main differences on why we should select 5-star animals. The first one is proliferacy again, or our weaning rate, in that we saw that our 5-star animals were weaning us about 1.7 lambs per ewe, whereas our 1-star animals were back at 1.54 lambs per ewe. So we can see straight away a lift in our weaning rate, or the number of lambs we actually have to finish from selecting 5-star animals. The other big difference we saw, it was in terms of days to slaughter, or the growth potential of the animals. So our animals from 5-star rams reached slaughter approximately 13 days earlier compared to the 1-star animals. So again, big differences in terms of flock performance, but what does that mean in economic terms or in profitability for farms? So again, we ran this through our bioeconomic model using all this real farm data to look at the economic potential. And what we saw there is that there was a big lift in terms of our economic or our profit in terms of expressing a per hectare basis or on a per ewe basis, where we saw that our 5-star animals were achieving an €18 more profit per ewe compared to the 1-star animals. So big lifts in performance could be achieved by selecting the right genetics for our flocks. Again, we wanted to follow this on and look at it from a greenhouse gas intensity. Could we select animals that were more profit, but also reduce our greenhouse gas in terms of our unit output? And again, this is coming from work that Jonathan has done, where I've highlighted the 5-star animals in the red bar here. The blue animals the 1-star animals are on the blue line here. Again, what we're seeing is the greenhouse gas intensity per unit of output was lower for 5-star animals, 7% lower compared to the 1-star animals. Again, we've more animals in the system, they're getting away to slaughter earlier, so it reduces our greenhouse gas intensity for the overall system. So good positive results from this, both in terms of our proliferation potential and also in terms of using our Eurostar indexes. They're selecting more productive animals with reduced greenhouse gas intensity. However, when it comes to the question of methane, and as Jonathan and Fiona have said, about 65% of the greenhouse gases coming from sheep is coming from the actual methane. So the next question then comes, can we actually select animals that have reduced methane as well as being more efficient? Fiona has mentioned the pack chambers that we have up and running now, where we've collected a lot of data to date on different animals across different environments. And what we wanted to look at then, well, was there differences in the genetic potential of these animals to breed animals that actually produce lower methane, while also giving us an efficient animal in terms of our weaning rate, days to slaughter, and all the other important traits. So what we did is we looked at the data that Fiona has already spoken about from a genetic point of view. And the first question we asked, well, is it under genetic control or is it heritable? So when we talk about heritability, what we're basically saying is how much of the difference between animals is due to the genetic potential. From looking at the methane data that we have on Irish sheep, we see that the heritability of the trait is about 25%. What that means in practice, if you had 2 sheep in front of you, 25% of the difference in the methane output between those 2 sheep is purely down to the genetics of that animal. It's not down to the environment that animal is in, or the management system, or the breed, or the parity. It's very much driven by the genetic potential. So it tells us we can make lots of genetic progress, or lots of progress in methane, if we understand the genetic potential of it. The other result that we got is that it's a highly repeatable trait as well. It's approximately 40% repeatable. If we compare this to other well-known traits like milk yield or live weight, it's roughly about the same level of repeatability as milk yield, slightly lower than live weight. And what that means is that there's a strong relationship between methane measured in a young animal and at a later stage in life, which again is a great result in terms of a genetic potential. So the next steps leading on from that then was to actually look at the breeding values. Could we develop breeding values for methane for our sheep? And this is just preliminary results from the data we have to date. But on this graph here, I want to highlight the blue line to start with. That's across the entire population of sheep that we have methane measurements on to date. You can see we've set the relative, or the average value to 0 here. So the average animal has a breeding value of 0. But what this also tells us is there's a large spread in the actual genetic potential of animals for methane output. So we have some animals up here at the extremes that are producing on average about 3.5 to 4 grams of methane, more methane per day than the average, who is down at 0. And then we have the really efficient animals in terms of methane down at producing almost 5 grams of methane less per day compared to their contemporary, the average animals or their contemporaries. So again, showing us there's huge variation within the breed, within all the animals we've looked at. Then we've looked at individual breeds. So I've highlighted here in the brown color, the Belclare breed, then the Charleys, the Texels, and the Suffolks here in green. Really what I want to show here is that there's huge variation within each of the breeds. No one breed is going to fix the problem of methane output or try and improve methane output from our sheep industry, because what we're seeing here is there's as much variation within each of the breeds as there is across breeds. So the next step,
Noirin, we've about a minute to go.
Perfect. I'm just finishing up anyway, Mark. So the next steps, now, is to actually start producing Eurostar or star ratings for these animals. So we want to start giving star ratings, the 1-star animals, to these animals that are producing a lot more methane relative to their contemporaries, and then 5 stars to the animals that are producing a lot less. Briefly to mention diets, as Fiona alluded to earlier, what we're seeing is that diets can have the diet that the sheep is fed can have a massive impact on the methane output. based on work that Fiona has done in Athenry, we see that there's a reduction in 12% in terms of methane output in grams per day when we introduce either clover, be that white or red clover, or plantain into our perennial ryegrass, as opposed to just a straight perennial ryegrass sward. So lots of potential coming from diet, and these are preliminary results that we will look at more in the future. So just to wrap up then, our key messages is the sheep systems here in Ireland, it produces a highly valuable nutritional commodity produced mainly from a grass-based diet, and often in areas of the country where we can't produce any more protein source. The average carbon footprint has now been shown to be by Jonathan's model at about 10.8 grams of CO2 equivalents per kilo of live weight. From Fiona's work, we know now that we have lots of methane measurements coming in quick and fast on sheep. Our packs, so our particle accumulation chambers, have been validated. We now have baseline data for sheep here in Ireland, and we saw from Fiona's work that there's a multitude of factors that affect methane, including feed intake and diet type. And I suppose the take-home message from it is that we know that in terms of the methane emissions coming from sheep, it's a small proportion of the overall in terms of the agriculture, the total agricultural sector here in Ireland. But it doesn't mean that we can sit on our laurels. We have to be proactive within the sheep industry to try and adopt mitigation strategies, be they management tools, using breeding, or using different diets. So that's a quick summary of it, and just again to highlight the Sheep Open Day that's coming up in Teagasc on the 18th of June.
Thank you, Noirin. Thank you very much, and thank you for keeping on time. We allowed a little extra time given the fact that we had 3 separate presenters this morning, and so lots of interest coming through the Q&A. But a reminder, if you do have a question for any of our speakers here this morning, do send them through to us. If I could maybe ask Fiona, you know, farmers looking at this morning's presentation, and they're looking at, there's lots of messages coming at farmers at different directions from a climate perspective, mainly at the moment. But what are the key recommendations you would have for farmers, or what would be the first step on the ladder to reducing your carbon footprint, and accepting that there's no silver bullet and that there are many different strategies, but you know, what would be the kind of, where would you see the low-hanging fruit here?
Yeah, so as you said, Mark, there is no silver bullet, and in most things in life there isn't. Noirin addressed so management, breeding and dietary factors that can help in our mitigation strategies, and I suppose those management factors, as we're terming them, are probably seen as the low-hanging fruit. So getting your soil fertility up to scratch, applying lime where you need to apply lime, using protected urea where possible, but also applying your compound fertilizers where they're required. You know, not putting out excess chemical in where you don't need it. You have to think about these things are also going to help your profitability, but also reduce your greenhouse gas emissions from your farm gate.
Thanks, Fiona. There was a question there I had for Jonathan, if you're joining us there. Yeah, perfect. Jonathan, you presented some figures there around the decrease in emissions since 1990, going from 1.6 to 1 megaton per year. Is that reduction, is that related to the number of animals as opposed to the actual intensity per animal? You're on mute there, Jonathan.
Apologies. Yeah, no, it's entirely associated with the population. So the inventory method uses a tier 1 method, so it doesn't fully take into account the productivity or the change in productivity of a ewe or its lambs. So it's purely down to the population. Okay. And it's largely down to the drop. There has been a drop in the lowland population, but it's primarily down to the drop in the hill population since the 90s.
Okay, very good, very good. And just on that, actually, we did have a question coming in around the difference between hill sheep production systems and lowland sheep productions. Is there a significant difference there between those types of systems, or do we know that in terms of their carbon intensity? I'm not sure if that's a question for you, Jonathan.
Oh yeah, no, that's perfect. No, and it's a good question. Sorry, now due to time constraints, I didn't delve too much into it. I just focused on the lowland. But yeah, we have done work on a comparison of lowland versus hills. And when we look at emissions per kilo output on a gross basis, so what we see is that the lowland is around 10.8 kilos of CO2 per kilo live weight. When we look at it for a hill system, it's 14. But when the important thing that, to add on to this is the potential for carbon sequestration. The lowland system or the hill systems are vastly less stocked. So there's more carbon, sequestered carbon associated with a hill lamb per kilo live weight than with a low lamb. So when you account for carbon sequestration, the emissions per kilo live weight is actually less for a hill system than a lowland. So it's when you account for carbon sequestration, it's approximately 9 kilos for a lowland and 7 kilos of CO2 equivalent for a hill. And just a point to add on to that is that the carbon is only one the carbon footprint is only one metric. You have to highlight the importance of the hill sector too, in that it's it's utilizing land that cannot be utilized for any other agricultural purposes as such, or has a low use of other agricultural purposes. So in terms of providing high quality nutritious meat, it is definitely serves its purpose and has a good there's a function.
No, it's a really important point. I mean, we can go chasing after carbon at the detriment of other metrics such as biodiversity, water quality, and like you say there, so there's a social aspect to this as well. So it's really important to take that holistic approach. Andy, some really good questions coming through from our viewers this morning.
Yeah, loads of questions. I'm not going to get through as many as we'd like, maybe. There's one very specific one there. Does the age of the sheep have any impact on the amount of methane that is produced by the animal?
Yeah, so I can take that, Andy. So it's a bit yes and no. As the animal ages or their level of production intensity increases, their methane output will increase. Yeah. But within an individual group of animals, so if you take a group of lambs, for example, that are all in or around, under the 12 months of age, you're seeing a negative relationship. So the younger animal will have lower output to the older animal.
Yeah, and and a couple of the presentations there, you spoke about the inventories and the work that we're doing to try and change, to go from, if you like, back to a more national inventory figure. Is there any idea when that, or have we any timelines of when we may be able to use those for our IPCC commitments?
So I can take it. At the moment, we don't have a timeline, and I suppose it's the same across dairy, beef, and sheep. But we are working with the government on it, and a lot of our Teagasc research is feeding directly into this. So we're hoping that, it'll be sooner rather than later. And
maybe for Noirin, there's a kind of a specific one. You showed the difference there between the 1-star and the 5-star per kilo of carcass weight. I presume it would be something similar if you were looking at it per hectare, or how would those figures stack up if you looked at it on a per hectare basis, Noirin?
So in per hectare basis, as well, what we're seeing is the greenhouse gas intensities is less for the 5-star animals, because you have that dilution effect in terms of you have more animals per hectare that's if you express it per unit of output. On a per hectare basis, be it the proliferacy study or the 5-star animals, we will see an increase in the greenhouse gases because you're carrying more animals on a per hectare basis. But I suppose the key thing to bring on from that, Andy, is the work that we're doing now at the genetic potential, so that in the future we can have potentially more animals or more efficient animals per hectare, but they are producing less methane at an individual animal level.
Yeah, and the final question here, Mark, maybe before I hand back to you. Does lambing ewes at 12 months versus 24 months for the first time have any effect on the overall farm emissions?
So again, it's work we have ongoing, and Fiona can comment on it as well, to look at that when we have all that data together. Based on what you'd assume, if you express your greenhouse gases per unit of output, you'd imagine you lamb your ewe earlier and she's lasting longer in the system, she's going to reduce your greenhouse gas intensity as long as she is lasting as long in the system as lambing at 2 years of age. So the more efficient animals is what we're seeing, is we're reducing our greenhouse gases per unit of output.
And sorry, Mark, I just get in one more. There's a few questions there around clover, and sometimes we talk about putting clover into new swards, but is there any work being done on keeping clover in swards? I presume the type of clover, whether it's a small leaf or large, it can be. Are you finding difficulty? There's a few questions here around the difficulty of possibly keeping clover in swards whilst on a sheep system.
Yeah, so I suppose two separate questions there, Andy. In relation to clover, so from our research work in Athenry, we are measuring animals that are on perennial ryegrass and clover based swards, and we are seeing a reduction in methane output. Through our farm-based work, so where we're going out onto farms, we will have animals on more permanent pasture, and we're also looking at the relationship between methane output and the pasture or the diet type that the animal is consuming. So that work is ongoing at the moment. And then in relation to keeping clover in the sward, so for sheep, you're looking for a small leaf clover. They're quite nifty animals at selecting what they like, a bit like us humans, and they will preferentially graze the clover out of the sward. So yeah, Philip Creighton and some of his colleagues here in Athenry are doing a lot of work on that, and there will be a lot of emphasis on it at the Sheep Open Day. So if you have a particular interest in it, I would recommend that you come along to that.
It's a really important point, because clover is a major part of the overall mitigation strategies for reducing our dependence on artificial nitrogen, and that is something I think that would be sustaining. I think is the challenge, isn't it? Sustaining the clover within the sward, like you say there. Noirin, just a question I have for you in relation to the slide you showed, stocking rates and weaning rates, and I was just wondering, how significant is that difference between the high stocking rate and the low stocking rate with the higher weaning rates? I think it was somewhere between 22.6 and 21, I think was the. But just how significant is that? Farmers are, working hard to have a higher stocking rate, but maybe would they be better off having the medium stocking rate? Just a question.
So in terms of the methane output, there's very little difference between your stocking rates. Where we're seeing the biggest differences is on the prolifercy, going from your 1.5, weaning 1.5 to 1.8. That's in a greenhouse. It depends, I suppose, how we express our greenhouse gas. If we express it per kilogram of output, obviously your prolifercy, or lifting your prolifercy, is having the bigger effect. In terms of stocking rate, what we're seeing, it's the same trend, that we'll actually we will increase our greenhouse gas emissions by increasing stocking rate, because we have more animals within that individual hectare. But I suppose it's a trade-off between efficiency in terms of our profitability and greenhouse gases. So there is a trade-off there to be had. You're lifting your profitability, but you are increasing your greenhouse gas intensity slightly at a per hectare basis.
Yes, and the way the emissions are measured at the moment, it is on that overall emissions, isn't it?
Yep.
Okay, I'm afraid we're out of time. We're a little over time, but thank you so much for those presentations, Jonathan, Fiona, and Noirin. We really do appreciate the time and effort that you have put in, and I felt they were very clear and understandable presentations as well. Sometimes it's not always easy to understand somebody's graphs and charts and so on, but you've honed those presentations very well over the years. Also, thanks, Andy, for helping with the questions, and I want to say thank you to Yvonne Maher for helping out in the background this morning. A reminder once again that Sheep Open Day is on the 18th of June in Teagasc in Athenry, and full details are available on the Teagasc website. So do go along, and I'm sure you get a chance to meet with Fiona and Noirin and Jonathan if you have any further questions on what was raised today. So thanks again, and wish you all an enjoyable long weekend. Next week, we're going to be joined by a representative from Keelings, who are going to be talking about their sustainability journey. So do join us next Friday at 9:30 for the Signpost webinar. So we'll sign out at that, and thanks again, everyone.